Hello students, welcome to IFAS. So IFAS family welcomes you. In this today's lecture, we will discuss about conductance. It's the part of electrochemistry. It's a sub part, or we can say it's like a subtopic of the electrochemistry. So let's start with this beautiful topic. It's having interesting concepts and many more much good equations and the formulas which we have to understand, and many new concepts and new things which you have to understand by the chemistry for the chemistry. Many new concepts and new ideas and many other relevant things and good things, understandable proportions, conceptuals examples are there. Okay, so let's start this. Conductance, as I already told, it's a sub part of the electrochemistry, subtopic of the electrochemistry. It is mainly of the, as what we have discussed till the, let's talk about till it's in the till class 11th. In the physics also we talk about the conductance, resistance, and the higher classes then also if we took physics there is also conductance. And in the for the chemistry portion there will be a little part of the conductance, resistance are there. So initially I'll briefly discuss the what are the types of conductance, resistance, and then what we need to discuss, what we need to study in this chemistry portion of this conductance. We will discuss that. Okay, first initially I'll give you brief introduction, brief summary of the types of conductance, and then we will discuss what we need to be covered in this topic. Okay, so basically the conductance is of three kinds as so far as we know, as using in the physics, chemistry. So there will be three types of the conductance. The first one is the metallic conductance. Metallic conductance clearly indicates that it is the flow of the conductance will be like conductance is the flow of something. What does we understand by the term conductance? Conductance is like as the flow of something. Resistance will be like a retardation or like it's a force of friction. In the movie something is going and there'll be a feeling of force of friction by which its speeds gets, someone if moving, the car is moving, its speeds get slows down or anything, that is the resistance. And the opposite of that, the rate of flow of something, that is known as the conductance. So conductance basically of three types. The first one is the metallic conductance. It means like it's based on the metals. How metals will conduct electricity. We all know that the metals are the good conductor of electricity. On what basis we can say that they are good conductors of electricity? As we know, for the resistance we talk about that as the electrons flow, the retardation in the flow of electrons, as the electrons flow through a wire in an electricity wire, what we have discussed in the class 11th physics, the current flow in a wire, the retardation in the flow of the current or the electrons charge is known as the resistance. And the opposite of that, the rate of flow of current, rate of flow of charge along the wire is known as the conductance, right? Rate of flow of current or rate of flow of charge is known as the conductance, right? So here in the metallic conductance it will be similar because the wires are also made up of metals. So here in this metallic conductance, the flow by which they conduct, the rate of flow, the substance which flow through the metals is the electrons. So here basically the electrons will flow, because as we know that in the wires are made up of metals. So metals, in the metals what are flowing? Electrons will flow, because metals can be ionized into an ion and gives the electrons. So the electrons will flow through the wire, electrons will move along the wire. The rate of flow of the electrons in a metallic wire or metal is known as the metallic conductance, and the retardation in the flow of those electrons is known as the resistance. So we have to talk about the conductance, so we will discuss that part. Okay, so the flow of the electrons is known as the metallic conductance. Electrons will flowing through the wire, right? The second type of conductance we know that this kind of conductance we will discuss in the resistance, we'll discuss in the physics. Wires, electrons are moving, retardation in the flow of the electrons from the wire, all that we discussed in the physics. But now we have to discuss the chemistry part of the conductance, So basically the second type of the conductance, which is known as the electrolytic conductance, right? Electrolytic conductance. So here the electrolyte is made up of, electrolyte is a salt which is made up of the acid plus base. It can be a strong acid, strong base, weak acid, weak base, strong acid, weak base, or weak acid, strong base. Electrolyte can be of any type, any type. So here in the electrolyte, as we dissolve an electrolyte of made up of any kind of salt, any kind of acid or base, as we dissolve any electrolyte in an aqueous solution, it will be dissolved again to get into the ions, and those ions then will flow, and then they will conduct the electricity. So as we know that there will be the many electrolytes, many compounds which is a non-conductor in solid state, but when we put it into a molten state or in the aqueous state, they will conduct. That is, they are known as the electrolytic conductors, because in the electrolyte, as we dissolve the electrolyte into an aqueous solution, it will get converted into ions, and ions have the positive or negative charge, and the charge species will move and shows the conductance, right? Charge species, here in the metals, electrons are flowing, negative charge species are flowing through the wire and shows conductance. And here in the electrolytic conductance, electrolytes give the ions, and those ions will flow and gives the conductance. So this ions flow, these ions will flow and shows the conductance. And this kind of the flow, this kind of the flow we will discuss, and the electrolytic conductances we will discuss in the chemistry portion, right? This we will discuss in the chemistry portion, right? We have to mainly discuss this part, because we are a chemist, we are a chemistry student, so we have to discuss this part, right? So electrolytic conductance, we will discuss that part. Clear? So next, third type of the conductance, which we need to discuss, which we need to study, is the mixed conductance. Mixed will be a mixture of something. So it will be a mixture of the metals and electrolytes. It is a mixture of the metals and electrolytes, right? Like that, give example like sodium ammonia, NaNH3, very beautiful, that reagent we will use in the organic synthesis, organic reactions, right? Organic reactions, we will use this NaNH3, use this reagent. So this will shows the mixed conductance. It will be a mixture of something, mixture of metal and the electrolyte. So here the conductors will be the species which will conduct the electricity, the species which will conduct, and the species which will flow through the system and shows the conductance is the ions and electrons. So ions plus electrons both. So mainly in the brief introduction, there are such three types of conductance. Which we already know. And the first one is the metallic conductance, which will be covered or discussed in the physics. We have to mainly discuss the electrolytic conductance, and there will be also the part of the mixed conductance, right? Let's talk about the next point regarding them. Effect of temperature on these different kind of conductance. Let's talk about the next point on them. Effect of temperature. Okay, so effect of temperature, talking about the temperature, as let's say talk about the first, we will talk about the metallic conductance. As if the electrons flows through the wire, if we increase the temperature of the wire, electrons will move here and there. If the, let's say it's a wire, in my hand it's a pen, let's suppose it's a wire, if electrons are flowing straightly from there, if we increase its temperature, and somewhere here, anywhere, if we increase its temperature, the electrons will shake, electrons will vibrate, electrons will move here and there. Initially, if we don't raise their temperature, the electrons will flowing straightly, they will show conductance, but as if we increase its temperature, the electrons will shake, electrons will vibrate, shake, it will be just shaken, it will be vibration, it will be under vibration, and thus their flow will resist, their resistance will be increases, and their conductance will be decreases, because as we increase their temperature, the electrons will shake here, anywhere, electrons will vibrate there, so that thus their conductance flow will reduce, resist, their conductance will be reduced, and their resistance is increased. So for the metallic conductance, if we increase the temperature, if its temperature is increases, its conductance decreases. If its temperature is increases, its conductance decreases. Clear? Similarly here, if in a for an electrolytic solution, because electrochemistry what we have discussed, we took a beaker, we put an aqueous solution of an electrolyte here, and we put then a cathode or anode electrode from which the charge is flowing, electron is flowing, electron is moving, conductance is going on, current is going on, there will be some resistance also, right? So basically what is happening here in the electrochemical cells, we took a beaker which have the aqueous solution, and the ions will flow from there, right? So basically this type of the conductance which we are going to discuss in the chemistry portion, and here we will discuss that. So here also, if we increase the temperature of the solution, the ions will move here and there, thus its conductance also decreases. So if we also increase the temperature, of the electrolytic solution which shows the conductance, if we increase its temperature, the ions will move here and there, and its conductance also decreases, right? Its conductance also decreases, because electrolytic solution initially showing the normal conductance, but if we increase the temperature, as like the electrons from the metallic conductance, the ions also move here and there, thus its conductance also decreases, clear everyone? Everybody got the clear point about that, right? Okay, moving on to the next. So it is the brief introduction of the chapter, brief introduction about the conductance. What is conductance? It is the rate of flow of species, to show the conductance, rate of flow of species, by which speed, or which flow the species will moving, and shows the conductance, shows the electrical conductivity, conducting nature, right? So moving on to the next, next we will discuss the next topic about that. So let's talk about the clear cut point about the resistance, starting from the back of the point, from the class 11th, discuss, as we discussed about from the, if we took it from the class 11th point of view, what we know about the resistance, it is known as the retardation in the flow of current, right? It is the retardation in the flow of current, right? It is the retardation in the flow of current, how much retardation, or how much is the force of friction in the movement of current, right? It is like that, retardation, or the resistance, force of friction in the movement of current. What we have discussed, what we know about its formula from the class 11th, that R is the symbol of the resistance, it is denoted by capital R, is equals to rho into L by A, where this rho is known as the specific resistance, or resistivity, all right? Specific resistance or resistance, it is an extensive quantity. Resistance is an extensive quantity. How it can be extensive quantity? Let's understand it. R is equals to rho into L by A. If wire is long, its area is large, the resistance value changes. So resistance will depend upon the extensive quantities, what, which depend upon the amount of substance, right? Extensive quantity is what? Extensive quantity is those quantities which depends upon the amount of substance. So resistance will depend upon the length of the wire, how much big is the length, or how small is the length of the wire, and also on the area of the wire. By looking at this formula, we clearly understand that the resistance depends upon the length as well as the area of the wire from which electrons are flowing, or for which we are going to calculate the resistance. So it is an extensive quantity. Clear? Everybody clear? Because it depends upon the amount of the substance, or amount of the species from which the electrons are flowing, or for which we are going to calculate the conductance, right? Specific resistance, it will be the specific value, constant value kind of for the resistance. Okay, so its unit is resistance unit is, the unit of resistance is ohm. The unit of resistance is ohm, which is also denoted by this symbol. The unit of resistance is ohm, which is also denoted by this symbol. Clear? And now mainly we are discussing the conductance. So as I already told you that the reciprocal of resistance or inverse of resistance is known as the conductance, because resistance has the definition retardation in the flow of current, force of friction in the flow of current, and conductance I already explained you that it is the flow of current, rate of flow of current, just opposite of the retardation. Retardation is like stopping, to stop someone, no go here, there, stop here. And conductance, flow of current, rate of flow of current, so it is just opposite of that. Conductance is just inverse of resistance, right? So if we write about the definition of conductance, it is the reciprocal of resistance. Clear? It is the reciprocal of resistance. Clear? Right? So conductance, it is denoted by capital C. It is denoted by capital C, conductance, right? Capital C, conductance. Okay, so which is the reciprocal or inverse of resistance, right? So what being the formula of the conductance? We can put its R value from here, from 1, let's say it is 2, put 1 into, we can do that. Put 1 into, what is the formula of conductance begin? C is equals to 1 by R, so it is the 1 by rho, or we can put it as like 1 by R is value rho into L by A, which will become as like C is equals to 1 by rho into A by L. L by A will get inverse, so L by A will get inverse, and it will become as the 1 by rho. Here this 1 by rho, is known as the kappa, which is also known as the specific conductance, or conductivity, Rho is specific resistance or resistivity. So inverse of rho is the specific conductance or specific conductance or conductivity. Resistivity ka inverse of resistivity is conductivity, inverse of specific resistance is specific conductivity. So 1 by rho is K, which is known as the specific conductance or conductivity. So what become the formula of the conductance? C is equals to K into A by L. If we put the values of this, so the unit of conductance, what will become is the unit of conductance? Conductance is inverse of resistance, right? So inverse of resistance, conductance is inverse of resistance. Resistance has the unit ohm, so the unit of conductance will become ohm inverse, or we can write it as this inverse, which is also known as the Simon, we can denote it as like capital S, Simon. Okay, clear, right? Okay, let's talk about this formula. C is equals to K into A by L. If we calculate here, if we derive here from the value of K, what will it become? K is equals to C over A by L, right? C over A by L, which will become as like K is equals to C into L by A. So what is here will be the unit of this specific conductance or conductivity. What is the unit of specific conductance then? Unit of this specific conductance. What will become the unit of this specific conductance? Conductance has the unit ohm inverse, or we can write it as this sign, ohm inverse, and let's say length has the unit centimeter. If length has the unit centimeter, then area will become as the unit centimeter square, right? So it will become as the centimeter inverse. We can write it as, we can also write it as ohm inverse centimeter inverse, or also we can write it as the Simon centimeter inverse. Specific conductance, which is the unit Simon centimeter inverse, ohm inverse centimeter inverse, right? Clear. So more point about that, more information about that we will discuss in the next lecture, next class further. Okay, so thank you so much guys. Goodbye, take care, have a great day. This is all from my side from today. Sayam Sikka from IFAS. Thank you so much guys.